Hello everyone, I'm going to make a quick video just on some of the basics and breaking down the various aspects of SN2 reaction, what helps, what doesn't help, things like that. So when we're looking at an SN2, just to kind of refresh our memories, we have, right? So, and we have a leaving group here, my leaving group pink, leaving group here, and I'm just going to turn these into hydrogens just for this moment, plus a nucleophile, right? Because it's a nucleophilic. We're talking about SN2. The N stands for nucleophilic. The 2 stands for bimolecular, meaning that this happens in one step. Boom. And my leaving group leaves in the next step. I mean, the same step. They happen at the same time. The result of this reaction is I'm going to have an inverted center, right? I'm going to invert the way it came in. So now I'm going to have my nucleophile here plus leaving group. And the focus of this little video will be kind of the role of the leaving group. So if you remember, we talked about the leaving group, and for the leaving group, the leaving group should be a weak base, and have a strong conjugate acid. Or it's a base from a strong conjugate acid, from a strong acid. Either way, they're saying the exact same thing. So let's look at 2 different species and see which one would be better for an SN2 reaction. Let's compare, and I'm going to move this up a bit. We're now going to look at, and I'm just going to do this as OH. So my OH here, and then it's going to be 1, 2, 3. So this is going to be R2 butanol. And below it, we will do the exact same thing, except instead of that, we're just going to have the alcohol be protonated. Okay? Sorry, it was shaking for a moment. And we're going to treat them both with the same nucleophile, Cl-. If we look at this reaction, what we'll notice is we're going to now have S2-chlorobutane in both of them. Whoops, sorry about that. But only one is really going to go forward. And let's look at our 2 leaving groups. This one I have plus OH minus as my leaving group. And this I have plus H2O as my leaving group. So now which of these two reactions do we think would be more energetically favored? Remember, we're looking for the weaker base, stronger conjugate acid. So the acid from H2O, if H2O is the base, its conjugate acid would be H3O plus. This is a weak base. It's not really a base, right? It's kind of water's neutral. This is a strong acid. Weak base. If I have H2O as my acid and OH as my base, this is a strong base. Strong base means it's reactive. This is weak acid, basically neutral. So therefore, based on this, my water would be the more favorable of these two reactions because it has the better leaving group. And remember, the same things that make something a weak base, a weak conjugate base, therefore strong acid, are the same things that make something a good leaving group, because it means once it breaks that bond, it's stable on its own. I'm going to stop here on this example, and next example, we're going to talk about the role of the nucleophile. Okay.